working as a data engineer with ABN Bev right now,
Yeah.
leading the data engineering capabilities for GenAI in our company. It has been a really good learning ride right now. Mostly working in cloud tech stacks like Azure and Databricks and stuff. So yeah, that's about me. You can go ahead with your introduction. You can tell like about little bit background about what you did like in your past experiences and what projects did excite you and what tech stacks you used to kind of come up with a solution. So yeah, over to you.
Okay, so currently I'm working as a senior analytics engineer with the modern data company. So currently I am here working for one of the clients, which is the largest distributor of wines and spirits in USA. So here I am working on building end-to-end data pipelines, as well as worked on data migration from various clouds. That is from GCP to AWS, as well as have built some of the data models, which is mainly related to customer, product, and sales, which completely aims to optimize their supply chain as well as supply chain inventory management and campaign optimizations. Post that, I was working with RTB Analytica as the data engineer, where I have worked on building several data pipelines from various programmatic advertising-based APIs, mostly which were related to DV360 Trade Desk, mainly aimed towards optimizing the bidding algorithms that actually happens at the demand side platform, and so as to display the ads and optimize the campaign and the operations. So the stacks that I worked upon is on Python, PySpark, SQL, Airflow, and right now currently in the modern we are mostly I'm using PySpark and mostly have worked with S3 and GCP buckets.
Okay. In your first project, I think in the modern data company, you said you were migrating from GCP to AWS, right?
Yes.
I mean, both are cloud platforms, right? So any reason for that?
Yes, so there was one of the problem statement for the customer, like because as their data was distributed across various platforms, but they were mostly using AWS as their main cloud. Most of the data that was on the GCP for the Google Analytics was mostly migrated towards the Redshift to have a one single source, so that the data analysis for the campaigns and the digital operations could be optimized.
Okay. So let's understand it in a very like in certain depth, like in your modern data company, like just tell me like one business use case that you solved, which was the most important and close to your heart, and how did you solve it? What were the challenges faced, and what was the requirement? How did you solve? Where did you come in? What did you contribute to? Like, I understand there will be a lot of other team structures also, right? The data science people will be there, the data engineering people will be there. So what exactly did you contribute to? That would be a better understanding for me. Like, what volumes of data you handled?
Okay. So like over here, I have worked over here handling 1 million records per day
Okay.
over here. Most of the data, so I worked on two things. One is on developing the data pipelines for migration, and another is to develop the data model.
Yeah, okay. Let's first start with the business use case. Like, what did you solve for? Like, basically, like what was the use case that you solved for? That I want to know.
Okay.
Yeah.
So the use case was mainly related to the campaigns. So where the customer was facing facing some of the problems related to their campaigns, where some of the campaigns in a particular region were running successfully, but the sales of their product of that particular brand was not increasing.
By
And
campaign, you mean marketing campaigns?
yes, marketing campaigns.
Got it.
And second was related to the inventory management, where at the real time the customer wanted to know if the when the when the products go out of stock,
Okay.
so that because this was the major issue which the customer faced as related to the churn, because the customers were churning because of some of the orders that were booked were completely going out of stock and were not able to deliver. So
Okay.
these were the two major use cases. And so the number one use case was for the GCP, where all the online operations related to the products on their website were actually brought to the Redshift, so that it could be compared with the offline sales data as well for those particular customers. So they were purchasing on two channels, that is some of them was happening through the online and some of them were happening through offline basis. So then there we compared the data, and based on which we had a one single source, we joined those tables, and on the basis of that, we developed few of the metrics over there for campaigns related to their bounce rate, open rate, and what rate they were clicks and conversion rates as well. So so that actually helped to identify few of the products in those particular regions which were getting sold at a higher amount of level. So what we did is this actually helped to eliminate that problem which the client was facing related to the campaigns. So the particular products which were popular in those areas, only their campaigns were had to be displayed, is what we analyzed. And so this actually improved their sales to only up to 60%. And then second comes for the product details. So where we analyze the product sales for both online and offline, offline data. So what we did is we calculated few of the metrics related to the products, compared their growth like month on month their sales, yearly sales comparison within the past 2 years. Like those, we developed a few of the metrics, and based on that, it actually helped. And also we calculated the inventory stats. That is mostly that was mostly daily consumption ratio. So where we compared the average 90 days sales with the current month of that particular product. That actually helped to analyze and compare the cases in hand and the sales every day that was actually happening. So which actually helped to know comparison of cases on hand and DCR, actually helped to calculate the the out of stock status for various products. So that is how the inventory was managed after that, and this also eliminated the problem of churning of customers and back order issues.
Okay. Okay. Got it. So I see in your resume you have mentioned quite a lot of numbers, like 20% you have saved on cost, 35% on performance you have increased. So I just wanted to understand on a very high level, like how did you reach these numbers, right? Like were you kind of uh, calculating these like before and after you did certain changes, or like is it a cumulative project achievement that the performance was increased by 35%?
Yes, so at the starting, when we started with it, the data was actually, there were a few problems that we have actually identified. Like most of the challenges that we faced was it was actually going out of memory error many times. So then we came up with few of the Spark
And why,
optimization.
and why was it happening, the out of memory error?
Okay, so because what we identified is that number one, the data was not partitioned,
Okay.
and secondly, the indexing that has to be done was also was actually also not there on the tables. So
Which
the two things,
data warehouse the data existed in?
it was in the data is in Redshift.
Okay, okay. And how did you index it then after that?
So mostly we used few of the SQL statements over there to index the column. Based on that, we actually came. So based on that, we indexed those columns.
Okay, got it. So, okay, like as we have reached on indexing,
Yes,
I would like to know, so have you heard about your RDBMS, right? You have heard about
yes.
RDBMS, any kind of relational database module. How would you ensure that, how do you ensure like best performance? So suppose there is a relational database where any kind of team, like an analytics team can come ahead or a data science team can come ahead and they are querying the data on a daily basis to kind of build some application out of it, or maybe build a reporting tool out of it, right? So there is a data warehouse, which is a RDBMS. Now, how do you ensure that every day, and on a D side, on a data engineering side, every day, certain pipelines run, and there is a daily refresh of data, incremental refresh of data that happens on the data warehouse.
Yes.
That might happen in the night, and in the daytime, a lot of teams work on this data, right? So how do you ensure that whenever the other teams they start performing query and optimization and trying to model some uh, things out of the existing data which have been ingested in the night time, how do you ensure that optimal amount of performance is given to them? Like when I say optimal amount of performance, it's that the latency is low, the query response time is low, there is an optimal query plan that is being generated for every certain SQL query. So what will be the steps that would ensure a good amount of optimum, result being given out to this team when you do a daily basis, ingestion, and also that data warehouse is being used for a transaction level, like reporting or building an application as such.
Okay. Yes. So for example, like there is one of the thing which you have to identify is one is the data should be partitioned on the basis of which you are filtering. For example, there was one of the use case like where customer actually wanted to know uh, to know the campaigns on the basis of on the basis of various sites or various states in United States. So that so based on that, you apply filter conditions, and those filter conditions where you apply the partitions, it will only pick the data from those particular folders. For example, if it is where I am giving in my condition where state is equals to Arizona, so it is going to, with the help of partitions, as the data will be partitioned, so it will only Spark will only go it will go and check in the folder of Arizona, and
But
from
suppose
there.
like there is no Spark kind of a big data, there is no
Yes,
data attached to your DBMS. Like think that there is no database attached to your like a data lake, like a S3 or a ADLS Gen 2, which is attached at the back end, where you have the file structured stored as such. Like your partition file structure, what you're saying right now, right? The Arizona state would be in a different partitions file so that the predicate pushdown happens and it will
yes,
only select the partition that is relevant enough for that
Relevant.
specific query. Suppose that is not there, like you are creating in a RDBMS where you have a direct data set which is not, linked to any other data lake storage which stores data in forms of partitions. I mean, you can do indexings, you can
Yes.
do like certain amount of optimization there, but still, how do you ensure performance if there is no as such partitions to be triggered on? Partitions or bucketing for that matter to be triggered on.
Okay, so you are saying that there is no partition on the data, but however, the indexing is there.
Yeah, your
So
data is indexed on the columns, that
yes,
are being filtered. Your data is indexed on primary keys and foreign key relationships also,
yes.
so that the hash maps are present. Your data is already there. But my question is, how do you ensure the optimal query plan being formed and your data is not defragmented every day while you write data to it, right? As partitions is not there, only indexing is there, your data has a chance, I mean, your database has a chance of getting fragmented, right?
Yes.
So how do you ensure that the optimal query plan is suggested and by the SQL server, the optimal query plan is suggested and also your indexes are in place?
Okay, so here comes the part of query optimizations. So where we will ensure like there are few of the conditions which you have to take care of. The number one is when you are using the inner joins, or when you are so you have to use the inner joins mostly instead of subqueries, because that actually consumes a lot of memory, which we have observed. And then further, in order to, when you are joining the tables, or if if there are a lot of columns, so then you have the CTE methods, like where you only select those specific columns which actually acts as a view at the runtime. And consider, like there are two tables now, customer and sales. So when you are trying to join these two tables, we have to ensure that since the order is will be the fact table, which will be large, and this will be small table. So here you have to order it on the basis of customer ID, and here also you can order it on the basis of customer ID. So like once you order it, so then it gets easy for for the indexed columns to identify all those IDs, which will further optimize your joins, and also reduce the latency time for that. And it is going to optimize the joins as well. So like you have to ensure like which table you are joining. If you are joining the small table with the big table, and so then this will take time. But when you are joining big table with small table, so then definitely it will occur more fast.
Okay, got it. I think you are talking more on the optimization side. So
Yes.
to give you a hint, like obviously you can do all these things, but specifically inner join that you said, right?
Yes.
So you should not use inner join. Why? Because you lose data, right? Suppose there are two tables, like you said, customer tables and sales tables, and you are
Yes.
trying to do an inner join. And anything that does not match between the customer and sales table falls off, right? So you lose data there. So ideally, inner join should not be your first uh, I mean, choice of join that you should do. It should be either a left join. I mean, a more important table that is on your left should be left joined with the right table. That ensures that you have the data in place, and whatever data did not match with the right table, it did not go through, and it separates, gives out nulls there. But my question was more on the query plan basis, query plan and indexes basis. So just to kind of answer this question is that you need to run maintenance activities. Like there are two kinds of maintenance activities that you run
Okay.
on a data warehouse. One is update statistics and one is rebuilding indexes. So if you do update statistics, so update statistics on all your schemas and table that you use or ingest data into on a daily basis. So if you update statistics and if you rebuild indexes, what it does is it kind of defragments the data and also it chooses the optimal query path so that it chooses the filters first, chooses the projections later, so that you get the faster query results on a daily basis. Obviously, what you told is more of a code optimization, like SQL code optimization
Yes.
techniques. What I was looking for was more of a like an infra level optimization that you can do. So you have to run a maintenance activity on a daily level, which can help you. Like that could be chosen like on a daily level or a weekly level. That is the choice of the organization, how to bear that cost. But your maintenance activity helps in this way. Cool. No problem. Let's go ahead with certain questions. So can you tell me, okay, you have worked on Databricks, you have worked on Delta Lakes, right?
Yes, I have mostly worked on PySpark, but I have some knowledge of working on Databricks and Delta Lakes as well.
Okay, so do you know how history is stored inside Delta tables?
Yes. So mostly the history is stored in the form of snapshots in the Delta tables. So like when you go into those files, so it is stored in the form of JSON, so where it will contain all the metadata related to the snapshots or order IDs, related to count of order IDs, and maximum and minimum values of those columns, of numerical columns, will also be stored over there in the Delta tables. So one of the major advantage while while working with Delta tables is like you can time travel through it, and you can based on if you want to analyze the changes between the current and previous version, you can compare those. Also, Delta table has one of the capability which helps to merge the data, the two tables on the basis of some IDs where you give conditions. Uh, so that's how the Delta table is, and everything there is stored in the form of JSON files and in the metadata and snapshots.
Yeah, there are two types of files. One is .json and one is .orc.
ORC.
Yeah. Okay. So you said so time travel, right? Time travel is one of the features that Delta table offers.
Yes.
What are the other features that you know that Delta table offers?
Like one of the feature is merging. One of the feature is like merging. Then you can also vacuum the data. Like if you want to, if there is some limit, like if you are storing the data only for 30 days, so that is on the basis of that you can vacuum few of the data, and then you can also roll back those tables, because mostly it will provide you all the asset properties. It will provide you all the asset properties as well as yes, it mostly provides you all the asset properties, and
What are the asset properties? What do you mean by asset properties? And what are these properties?
okay, so asset property is mainly atomicity, integrity, atomicity, consistency, isolation, and durability. So the atomicity will ensure the data should be it should be everything should be unique, and then consistency is mainly whenever, for example, if you are transferring the amount of money, so for you have transferred the amount of money to to your one of the friend. So here it will update the data that it has been transferred, and it will be updated over there as well to which person you have transferred. Then another part comes that is durability. Like for example, whenever the any changes has been happened, so it should be permanent. In case of any system failures, or whenever the system crashes. And then comes the isolation, where the results for example, whenever any transaction that you are doing should appear only in some sequential order. For example, if the customer address has been changed, so there we are using some of the surrogate keys. So we must ensure that it should come only after the maximum surrogate key or something like that. So that is all about the asset properties.
Okay. What do you understand by normalization? And you have heard about normalization, right?
Yes.
So what is normalization and what is denormalization, and like what are the types of normalizations that are there as of today?
Okay, so normalization is the way, what we can say is to arrange the data in such a way so that is to reduce the amount of redundancy on the data. Is for example, if you see the sales table or product table, so whatever the sales table, product table, that will have a lot of redundancy related to the orders and items, whatever the various customers has purchased. So in order to reduce the redundancy, we divide it into some small tables, which has some links on the basis of their IDs, which has that we can say as dependencies. So here are various forms of normalization: 1NF, 2NF, 3NF, and BCNF. Yes. So the 1NF will ensure that whatever the record that you have, it should be if ID is 1, so then only those records should come. And if ID is 1, and in 2NF, for example, there are tables that which first of all, it should be in first normal form, and 2NF ensures that, for example, if there are two things which are linked, there are 3 columns, and the name is linked with the product name is also linked with the product ID, and it is also linked with the product is also linked with the cost. So there we can create a separate table with the product ID and product cost, and one table with the product as well as with all the product details. So that ensures the 2NF. And 3NF is similar to that. There will be more columns that has dependencies. So based on that, we will again divide those tables. And then denormalization is mostly achieved on the basis of joining those tables, which will give you a white table array, which will be mostly useful, which can be mainly useful for analytics kind of things.
So you said white table, right? So there are two types of table. One is white table, one is long table. Which one, like just quickly, which one is more preferred for a aggregated reporting style? A wide format table or a long format table?
And mostly we prefer white table transformation, white table for analytics kind of things.
Okay. So we will do two questions, one a simple Python question and one SQL window function question. Okay.
Okay, sure.
So I will paste the table here. So suppose you have the table, right?
Yes.
Now the question would go like, yeah, you can see, right?
Yes, I can see.
The format that I want the answer in will be so I want product ID, sales amount, total sales, and sales percentage. So this is the output that I want. Okay.
Okay, product ID, sales amount.
So you don't need the third table, like the second table. You can
Okay.
So this is one table, sales table, which has product ID, which is repeating, right? 1, 2, 3, 1, 2,
Yes.
1, 2, 3. And then there is sales amount, which is
Yes.
a numeric amount for each of this product. What you have to find out here is calculate the total sales amount for each of these products, okay? Along with the percentage of total sales that each product represents, okay? So total sales of each product. Now, if I say 1, 1 and 1, the total sales would be around 1000 plus 1200 plus
1200,
1300, right?
1300. Yes.
Is the total sales of each product. Now that will come in under the total sales bracket, right? And
Yes.
percentage of total sales that each of this product represents. So what is the percentage? Like suppose
1000 divided by plus of all the three numbers.
exactly. That is what. Okay. You can start writing a SQL query to give out the answer.
Yes.
Cool.
Sure. Okay, so what I will do is I will first select product product ID. Then I will do sum of sales amount column. So this is going to give me total sales. So this is going to give me the sales amount over here. And for calculating the total sales, what I will do is okay, so here I will use CTE concepts. So here I will create two CTEs. Okay, so one is for the total sales of the products. So here I will divide this sales amount divided by this total. So yes, so this is so this will going to give me like this. So this is going to give me the total sales percentage based on the product. So what I have done here is firstly I calculated the total sales of each product that you have said. So what will it does is, so by product ID, for example, it's product ID 1. So it will calculate 1000, 1200 and 1300. So based on that, this is going to give me the total sales amount for each product. And then here comes the product ID only with the sales amount. That is the same sales table that I'm taking. And then these are the two CTs that I've created. So from here, then I will join these two. And on the product ID, so on the basis of which it is going to give me product ID, and then product ID sales amount. Sales amount is mainly related to all these amount for the products, and sales amount total, which is the sum of all these three of each products. So then here, this will be sales amount will be divided by overall sales of each product. For example, 1200. For example, it is 1000. So this will be divided by sum of all these three in this total sales amount. So that is how it is going to give me as sales percentage.
Okay, so you join by product ID, right?
Yes, I join my product ID.
Cool. And you did a inner join here.
Yes, I did an inner join.
Acha, Manasa, can you scroll down? I think I'm not able to see the Okay, from sales to. Okay, cool, perfect. Okay, let's go to the next question. Well, I mean, obviously, a feedback here would be this would get you the answer, but it would take more time. Why? And also more processing, because you would be joining, right? In the first place, you would be joining
Yes.
these cities, which is again an expensive operation if
Mm-hmm.
the data size is more. Secondly, is that you are using a group by aggregation, which is also a transformation, which
Yes.
would kind of is a costly operation, and you're creating two CTs, which kind of is a temporary table, which kind of eats, temporary space also. So a better approach to this would be using window function. You wouldn't have to use any joins, any CTs, or any group bys. So just to give you a glimpse of that, I'll paste the solution here. You can go through it later. I mean, you can copy it in your notepad. So if you can check the solution, I have pasted. So it's mostly saying product ID, sales amount, sum of
Yes.
sales amount over, and inside your over clause, basically you will say partition by product
Product
ID.
ID. Yes. Yes,
Product
that is also the solution.
Yes. So here also and here also. So once you partition by product ID, you get sum of sales and sales amount by sum of sales into 100. And as I said percentage, you need to do into 100 also. That is fine. You divide it, but after that into 100,
Yes.
to give you a percentage also. Fine, no issue. Let's move on to the next question quickly. I pasted. Yep. So you can see.
Yes.
Okay, so given a 32-bit integer, okay, so any integer for that matter, which is 32-bit, I need to reverse that integer. That is the basic problem.
Yes.
So suppose x is 1 to 3, I need 3 to 1. If it's minus 1 to 3, I need minus 3 to 1. If it's 120, I need 2 and 1. I don't need the 0.
Yes. Okay.
And I need, because you understand, right? This is 0 to 1.
Hmm.
I don't need the 0. Okay. And if it's 0, it's 0. So write a Python code that achieves this and try out all these inputs like x, 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 and x. All these 4 inputs should work. That's it.
Okay. Okay. So I think for this we will mostly so what I will do is like here I will give an integer we will do one of the thing like where we will take the digit and then we will divide it by 10 modulo 10, which will actually give us the remainder, and then we will keep on storing the remainder. So based on which this is so this will going to give us the reverse number. So for this I'm just writing the code now.
Okay.
um I'm just taking this number, the reverse number is actually here 0. So I will iterate through it while x is not is equals to 0. So once I go here, so here I will give a particular digit, which when for this is the number which will divide it by modulo. So this is going to give the remainder. Okay, so the digit here we can tell it as the remainder. Whatever the digit is here, we will store it at the first place.
So
Uh,
123, if I take as example, 123 modulo 10, right?
yes.
So what
So
would be the remainder?
3 will be remainder. So 3 will come at the first place.
Hmm.
So here I will take one digit r, which will be known as the, so when I will multiply it by 10, plus that remainder.
I think plus digit.
Oh, sorry, yes, that digit. So this is going to give me like if I multiply this will be multiplied by 10 and then plus that digit. So definitely this will be going to be 3 at the first. So when coming to that, upon that, then again I will divide it. This will be the number which I will every time I will divide it by 10, so that I can go ahead from that number. For example, if it is 1, so then for example if it is coming 3, so then I now I don't want 3 because this has been come over there. Then again it will go to 2, then again the remainder will come to, then it will get stored to this place, and then r will be multiplied by 10 plus which will give you 32. Then then again now this number is not needed for me. Now 2 is not needed, so then it will go to 1, and then again the same process will happen, and then that is how you get 3 to 1 as the output.
Okay, so you use the palindrome approach.
Yes, palindrome approach.
To reverse the number.
Yes.
Can you think of a approach that would solve it in, I think, 1 to 2 lines? I mean, there is. So suppose, okay, how do you
Yes.
reverse a string?
Okay, so but then that is for the strings, right? Where I will just only have to convert this digit to string, and then uh, we use colon -1.
Exactly.
So that is how it will reverse that. It will actually reverse that
So
that
str of
number.
like str of x. So str of x bracket colon
str of
-1,
yes,
right?
yes. So this will reverse, but why do we need to convert it to string? But it is definitely an integer only. So then that is why I
It
preferred
is an
this method.
integer. Yeah, of course. That is right that you preferred the palindrome, but what it does is also runs a loop through your number, right?
Yes,
Right. So suppose where does it kind of sticks is like it's 1, 2, 3, 120. These are small numbers. Suppose you have a huge number, right? Which is like more than, trillions or zillions number of digits are there. There, suppose a string reversal is quite faster than, going through a loop for each character and extracting digits. So in the fast sense of way, so in the string also, like in a string reversal problem also, you will face a challenge where you have -123. So it will be 1, 2, 3 and hyphen, right? That is something you need to capture. Like if it's negative, how do you solve it? If it's positive, it's straightforward. 1, 2, 3
yes,
becomes 3 to 1. But if it's -1, 2, 3, in a string reversal way, it would be 3 to 1 and hyphen. So we need to capture the hyphen and put it in the first place and reverse the string slicing. So
yes,
S1 colon. So whatever is S from first place onwards, we reverse that and then put the minus ahead. So it's I mean, just a quicker method when you have a large number, or suppose you have a huge column
yes,
which you need to reverse as such. There is where the practical application comes. This is obviously a logical way of doing it. What you did is not, I won't say it's wrong at all. It's right. But yeah, just feedback that you can do it in a rather simpler way. But yeah,
yes.
good.
All right.
Yeah, I think that's all from my side. You have any other questions that you need to ask?
Well, so no, right now no such questions.
Okay. Okay, cool.